This is the Edexcel Modular, March 2011, Unit 2, Number, Algebra and Geometry. Question 1 is an nth term question. What is the next term of this sequence? Well, from 5 to 9, you've added 4. From 9 to 13, you've added 4. From 13 to 17, you've added 4. So from 17, you add 4 and that takes you to 21. Part B wants you to write down an expression in terms of n for the nth term of the sequence. Let me zoom in. So we've already identified that the sequence goes up in 4. If it goes up in 4, then we know that it begins with a 4n. This is because 4n represents 4 times any number, which is essentially the 4 times table. So what we're dealing with here is a sequence of numbers that I can equate to the 4 times table. Now the 4 times table would be 4, 8, 12, 16. What I need to do is work out how my sequence differs from the 4 times table. So how do I go from 4 to 5? Add 1. 8 to 9, add 1. 12 to 13, add 1. So the nth term for my sequence is 4n, add 1. With regards to mark, that's a 1 mark question for getting it correct. For this question, it's worth 2 marks. So 4n plus 1 will give you 2 marks. 4n plus any number that isn't 1 will give you the first mark. Question 2 is a ratio question. Ali, Ben and Candice share £300 in the ratio 2 to 3 to 5. How much money does Candice get? So first thing I need to do is set my question out. Ali, Ben, Candice in a ratio of 2 to 3 to 5. They're going to share £300. Now the first thing I want to do with ratio is find out what my total number of parts are. So I add those together. 2 plus 3 is 5 and 5 is 10. So there are 10 parts altogether. Now I've got to share that £300 by those 10 parts. So £300 divided by 10 equals £30. And what that's found for me is 1 part. Now the question is asking, how much money does Candice get? Now if 1 part is worth £30 and Candice gets 5 parts, we're looking at Candice getting 5 lots of £30. So Candice gets £150. This is a 2 mark question. You get the first mark for totaling the ratio up and showing 300 divided by your total number of parts. That's where your first mark comes from, M1. And your second mark then is for the correct answer. Question 3 is asking you to draw a straight line graph. Now it doesn't ask for a straight line graph in the question at all. It just says draw the graph of y equals 2x plus 3. However, I know that this is a linear equation and therefore it's a straight line. Because that number there is a positive, it's going to be going uphill. If that 2 was a negative, it would be going downhill. But that's why I know it's a straight line graph, is because there's a linear equation. Now, they've been a little bit cheeky in this question. We are probably quite used to seeing straight line graph questions come with a table of values. However, more and more increasingly, they're not giving a table of values anymore. They're expecting you to make your own. So if they do not give you a table of values and they want you to draw a graph for anything, then draw one where you're going to put your values of x and your values of y. and y, remember, is 2 lots of x, add 3. Now they're telling you they want the values of x from -3 to +1. So they want -3, -2, -1, 0, and 1. Now I'm going to find the values for y. So when x is -3, y is going to be 2 times by -3, which is -6. Add 3 is going to leave me with -3. When x is -2, we've got 2 times -2, which is -4. Add 3 is going to leave me with -1. When x is -1, that's going to give me 1. When x is 0, 2 times 0 is 0, add 3 is 3. And 2 times 1 is 2, add 3 is 5. So now I have my table of values. I can put them into coordinates so I can fit them onto my graph. Now, the reason I can get coordinates from these is because I've got an x value and a y value. And coordinates are always written as x, comma, y. So this here would be the point of x being -3 and y being -3. That would be x being -2, y being -1, and so on for the others. So I'm going to plot my graph now. So I've got -3, -3, so that's there. I'm plotting with an x. I've got -2, -1. I've got -1, +1. I've got 0, 3. And I've got 1, 5. And I'm going to put my ruler up against them and just check. Yeah. Oops. So all my points fall on the same line, which means I've substituted them all correctly. If I did have a point that ended up over here or off the line somewhere, then you've probably done your table of values wrong and connect the line through the majority of the points. Question 4 is a lowest common multiple question. However, you'll probably look at it and find a slightly more straightforward method of doing it actually. I'm going to do the straightforward method, but you can use any method which would get you a lowest common multiple. Okay, Vina bought some food for a barbecue. She's going to make some hot dogs. She needs a bread roll and a sausage for each hot dog. There are 40 bread rolls in a pack. There are 24 sausages in a pack. Vina bought exactly the same number of bread rolls and sausages. Exactly the same number. That's my aim. The same number. How many packs of bread rolls and packs of sausages did she buy? What am I dealing with here? I'm dealing with bread and I'm dealing with sausage. Now, bread, 1 pack is going to get me 40 bread rolls, and 1 pack of sausages would give me 24 sausages. 2 packs of bread rolls would give me 80 rolls. 2 packs of sausages would give me 48 sausages. 3 packs of bread rolls would give me 120 bread rolls, and 3 packs of sausages would give me 72 sausages. 4 packs of bread rolls is going to give me 160 bread rolls, and 4 packs of sausages would give me 96 sausages. Now, because my bread is way ahead of my sausages at the moment, because they're the smaller packs, I'm just going to stop adding on to my bread just to save me some time, and I'm going to catch up with my sausages. So if I was to buy a 5th pack of sausages, I'd have 120 sausages, and as if by coincidence, I just happened to find that the first number common to both packets is 120. So that means I need 3 packets of bread and I need 5 packets of sausages. So make sure you write them in the correct place. Bread, 3 packets, sausages, 5 packets. And they've been actually uncharacteristically nice with this question, because they've actually put a second step in. And so they've given you a hint here that the first thing you would have to do is to find the lowest common multiple. And then they're telling you how many hot dogs can she make. It's highly likely you'll have that question also buried in here somewhere. So be aware it might not always be laid out for you. But how many hot dogs can she make? Well, she has enough rolls and enough sausages to make 120 hot dogs. And that's a 1 mark question for part 2. With regards to the top part, you get 1 mark for attempting multiples. For attempting multiples of 40 or 24, you need to have done at least 3, and you are allowed errors as long as your intentions are clear. You get an answer mark for having 3 and 5. Just searching for the other marks on the mark scheme, you actually would get a second mark there, because you get 1 mark if you've attempted to list the multiples of 1, and you get 2 marks if you've attempted to list the multiples of 2. Now your 4th mark is going to come from showing that you are finding the multiples. And there's your answer mark for that, and then this is worth 1 mark down here for 120. And that's a 5 mark question. You'll be lucky to get that in an exam. Question 5 is a total surface area question, and as the name suggests, you need to find the area of all of the surfaces and then total them, so add them together. Do not make the mistake of seeing a 3D shape, especially a prism, and thinking, ooh, this is a volume question, I'm going to times everything together. To approach this question, the first thing I'm going to do is identify the faces and the shapes of those faces. So the first one that jumps out to me is actually the triangular face at the front. And because this is a prism, that triangle runs all the way through it. So the triangle at the back is the same as the triangle at the front. So first thing I'm going to do is find my area of one of the triangles. I'm going to start by writing out the formula, which is half of the base times by the height. And in this case, I've got a base of 12, so I'm doing half of 12 times a height of 5. 12 times 5 is 60, so I'm finding half of 60, which is 30. I'm dealing in area, that is centimetres squared. Now that's for one of the triangles. However, I've got one at the front and one at the back, so I actually need to times that by 2, because 2 of the triangles is actually going to be 60 centimetres squared. So that's the triangular faces done. Now I need to do the flat faces. So the first one I'll do is the bottom one here, and if you look, that is a rectangle which has 1 dimension of 12 and 1 dimension of 10. So I'm going to call that area of the base equals base times height, or length times width, or whatever you want to do, but it's 12 times by 10, which is 120, and it's area, so it's centimetres squared. So that's that face done. I'm going to find the back now. So area of the back equals, alright, well it's got 1 dimension, which is 5, and it's got that depth there, which is 10. So the area of this back is going to be 5 times 10, which is 50 centimetres squared. And I've got one more face left, and that's this front sloping face. So I'm just going to call that area of the slope, and that's got a depth there of 10 and it's got a width of 13, so it's going to be 10 times 13. So 10 times 13, which is 130 centimetres squared. So now I've found all the individual areas, I need to make a big statement that I'm finding the total surface area. And I need to show the examiner that I am going to add all of my values together. So I'm going to take the 120, add it to the 50, and add that to the 130, and not to forget my 60 from the two triangles. Notice how I'm keeping the place values and keeping all the tens under each other. This is a non-calc paper, so you're going to have to be quite organised with your workings out. 2 plus 5 plus 3 plus 6 is going to give you 16, 6 down, carry the 1, 1, 2, 3. So you get the answer of 360. I'm going to write it on the answer line as 360. Now at this point I've just taken a massive smile, alright? Because I know the answer is 360 and I know I'm dealing with area, which is centimetres squared. But usually they would have given me a cm squared on the answer line. But the very fact that they haven't given me a centimetres squared means that regardless of how I attempted that question or what answer I got, I would always get 1 mark for putting centimetres squared on my line, because centimetres squared goes for area. So that's where one of those 4 marks. Now the rest of the marks, you obviously get your answer mark for 360. You get a method mark for finding the area of the triangle, and you get a method mark for finding any 2 or more of the other faces. Question 6 is a question about the interior-exterior angles of a polygon, and there's a couple of rules you can learn for this, but the most important, I think, is probably that exterior angles is equal to 360 degrees divided by the number of sides, and using that reasoning, the number of sides is equal to 360 degrees divided by the exterior angle. So in this case, it's given me the interior angle of a regular polygon is 160 degrees. The fact that it's regular means all the sides are the same length. So they want us first of all to write down the size of an exterior angle of the polygon, and then part 2 wants us to work out the number of sides of the polygon. Again, they've been a bit too generous here in splitting the question up for me. It's highly likely that in an exam they will just expect you to find the number of sides of the polygon, and they'll expect you to take that step yourself. So first thing I'm going to do to find an exterior angle is extend one of the sides, because the exterior angle is the angle that makes a straight line with the interior angle, and the fact that it makes a straight line means that we can do 180 degrees. Take away that 160 degrees, leaves us with a 20 degree exterior angle. So there's my exterior angle. Now work out the number of sides of the polygon. Well, that is 360 degrees divided by the 20 degrees, which was my external angle. And because they're sort of tricky numbers, 360 divided by 20, if I was to look at it as a fraction, which would be 360 over 20, I could see that my zeros would cancel down, and it's the same thing as 36 divided by 2, which is 18. So my polygon has 18 sides. As for marks, here for 20 you get a B1 for getting the right information to find your exterior angle. Here you get an M1 for doing the correct calculation to find the number of sides, and as always you get an A1 for getting the correct answer. Question 7 is another area question, and it's asking you to find the area of the shaded region. Now before I even attempt this question, I'm going to use it to back up the previous point I made in the last question, and that is, it's an area question. Look at the answer line. They've actually printed for you centimetres squared. So make sure that you look on the answer line, because if they haven't given you the unit, you get a mark for putting them in. Now, trapeziums tend to make people panic because they can never remember how to find the area of a trapezium. But you do not have to remember the area of a trapezium because it is given to you on the formula sheet at the front of your paper. So if ever you see a trapezium and you're panicking because you don't know what to do, then it's worth having a look at the formula sheet. And the same goes for any shape that you see that you think, oh, I'm not entirely sure how to approach that. It's worth having a look on the formula sheet, because it might spark some memories. Okay, so I'm going to start with the big trapezium first. So I'm just going to make the statement here, area of big trapezium. I'm going to start with my formula, and it's half of A plus B, where A and B are the parallel sides, multiplied by the height. Now that is the perpendicular height, it's not the slanty side. Okay, you do not use a slanty side when you're finding the area of a trapezium. It's always the one that's perpendicular or straight up. So that is half of, my parallel sides of the big one are the 8 and the 10. So half of 8 plus 10 times by my height, which is 6. So 8 plus 10 is 18. Half of 18 is 9. 9 times by 6 equals 54. Its area, so it's centimetres squared. Now I'm going to find the area of my small, and again it's half of A plus B, which is 5 plus 7, times by the perpendicular height, which is 3. So 5 plus 7 is 12. Half of 12 is 6, times by 3 equals 18. Its area, so it's centimetres squared. Now I'm going to find my shaded area. And to do that, it's the area of the big one, which was 54. Take away the area of the small one, which is 18. And that leaves me with an area of 36 centimetres squared. But like I said earlier, we don't get a mark for the units this time. This is a 3-mark question. You get 1 mark for correctly finding the area of a trapezium, and remember we lifted that from the front formula sheet. So you get 1 mark for that. You get the second method mark for showing that you're subtracting your small area away from your big area, and you get an answer mark for 36 centimetres.